So 7.6, we're looking at some applications to rational equations. So in this one, they tell us that the ratio of the weight of an object on planet A to that on planet B is 100 to 3. So we have a ratio, planet A to planet B. That can be written as planet A over planet B. That's the ratio. And that ratio is 100 to 3, 100 over 3. Good to label this way so that we'll know which one corresponds to which. So if you weigh 100 pounds on planet A, you would weigh 3 pounds on planet B. So they tell us that an elephant weighs 3,600 pounds on planet A. So 3,600 pounds goes on top, and we're trying to find what its weight is on planet B. So we have to maintain the same ratio. So we set those equal to each other. And the way they're going to handle this is anytime we have one fraction equal to another fraction, we can just cross multiply. We can do 100 times B, 3,600 times 3, 3,600 times 3, and those two things are equal. Now that's only going to work if it's one fraction equal to one fraction. If there's more than one term on either side, we can't cross multiply. You could also see it as just clearing fractions. To make the 3 go away here, we would have to multiply both sides by 3. To make the b go away, we would have to multiply both sides by b. When we do that, the 3's would cancel, leaving us 100 times b. The b's would cancel, leaving us 3,600 times 3. To get b by itself, divide both sides by 100. So b is 10,800 divided by 100, so 108. So an elephant on this other planet would only be 108 pounds. All right, so this next one deals with how long it takes someone to do some work. So if one person, let's call them person A and person B. For the first person, it takes them 5 hours to do a certain job. The other person, it takes them 6 hours to do the job. So if they're working together, it's going to take less than 5 hours. If just this person does it by themselves, it would take 5 hours, but if somebody's helping them, it's going to take less time. So we got to find out, well, how much time will that be? So the first person can do 1/5 of the job per hour. They have one job and takes them 5 hours, so they can do 1/5 of the job every hour. Notice if he worked for 5 hours, 5/5 would be one whole job. This other person can do 1/6 of the job per hour. Notice if he works for 6 hours, 6 times 1/6 would be 6/6, or one whole. So we're trying to find out how many hours is it going to take to do the whole job. So if it's 2 hours, this person does 2/5 of the job, and this person does 2/6. If it's 4 hours, this person does 1/5 4 times, or 4/5. This person does 1/6 4 times, so 4/6. So we don't know how much it's going to be. We just know when we add the amount of work this person does plus the amount of work that person does, it totals one whole job. So we do x times 1/5, or x over 5, x times 1/6, or x over 6. So this is going to tell us how much of the job each person does. So again, for example, if they worked for 3 hours, this person would do 1/5 3 times, or 3/5. This person would do 1/6 3 times, or 3/6. So when we add the work from the first person plus the work from the second person, we need that to total 1. So that gives us a rational equation. We need to make the fractions go away so we can solve this. So we find our greatest common factor, or our least common multiple, which would be 30. 5 goes into 30 and 6 goes into 30. So we're going to multiply everything by 30. We're going to do 30 times the first term, and we're going to do 30 times the second term, and we're going to do 30 times the other side. And why 30? Because 5 goes into 30, and because 6 goes into 30. So that makes our fractions go away. We have 6 times x plus 5 times x. Well, those are like terms, 6x plus 5x. And then to get x by itself, divide both sides by 11. So x is exactly 30 over 11. Or as a decimal, about 2.73 hours. So if one person can do the job in 5 hours, the other person in 6 hours, then they can do it together in less than 3 hours, 2.73 hours. Okay, now the next problem or two is going to deal with rate, distance, and time. So we need to know what the relationship is between rate, distance, and time. Rate times time equals distance. If you know how fast you're going and you know how long you're going that speed, multiply those together and that will give you how far you've gone. For example, if you're going 20 miles per hour and you go 20 miles per hour for 2 hours, that's 20 miles in the first hour and 20 miles in the second hour, or 20 times 2, and that would give you 40 miles. So rate times the time, that equals the distance. So in all these problems, we're going to make a table, a chart, and that's going to help us organize our information. We're going to fill in each row, we're going to fill in 2 pieces of information, and then we're going to find the third piece using the first 2 that we know. So it says a jogger begins her workout by jogging to the park 20 miles. She then jogs home at the same speed but along a different route. This return trip is 24 miles. Her time is 1 hour longer. Find her jogging speed. So they say let R be the jogging speed. And they tell us that the speed is the same for both pieces. So if R stands for rate, her rate on the trip to the park is R, and her trip coming back, the speed is also R. So we have 2 of these pieces filled in. We need to fill in time. Well, how is time related to distance and rate? If we take rate times time equals distance, if we solve this for time, we would be dividing by R, so that those R's cancel. So time is distance divided by rate. So to get this time, we take the distance here divided by R, the rate. To get this time, we do this distance divided by that rate. So this is an expression for how long it takes for her to jog to the park, and this is an expression for how long it takes her to come back. So then they say something else about the time. The trip back is 1 hour longer than the trip to the park. So if we knew this time, this one is 1 hour more than that time. The time to come back is 1 more than the time to the park. So the time to the park plus 1 hour is how long it takes to come back. So we just use that relationship to write an equation once we had an expression for both times. Now we solve that equation. We have fractions with r on bottom. We want to make r's go away. So we're going to multiply each term by r. When we multiply the left side by r, the r's cancel, giving us 24. When we multiply the first term on the other side by r, the r's cancel, giving us 20. And when we multiply the last term by r, we get r. Our equation doesn't have any fractions. Subtract 20 from both sides. And we've got r by itself. Find our jogging speed. So our jogging speed is 4 or 4 miles per hour. Okay, let's take a look at this one. So this one deals with trains, and they're leaving a station at the same time, and they're traveling in opposite directions. So if the train station is here, one is going in this direction, one's going in the opposite direction. So let's call this part train A and this part train B. And here's the station. We're going to make a table. Part for train A, part for train B. And we're going to put rate, time, and distance in. And let's get this down so we've got it right. So what do we know? We know that train B travels 10 miles per hour faster than train A. So if we call the speed for train A R, train B is 10 miles per hour faster. So whatever this speed is, this one is 10 more than that. 10 more means plus 10. In 2.5 hours, the trains are 225 miles apart. So they're starting here, and then they're going for 2.5 hours. So train A goes this way for 2.5 hours. Train B goes that way for 2.5 hours. So each of them have a time of 2.5 hours. Now to get distance, distance is rate times time. So once we have two of these filled in, we multiply them together. R times 2.5, or we could call that 2.5R. That times 2.5, or we could call that 2.5 times R plus 10. So this is how far train A goes. And this is how far train B goes. Now, when that 2.5 hours is up, they are 225 miles apart. 225 miles apart. Now, we don't know how far either one of them have gone. But when we take the distance that train B has gone and the distance that train A has gone, since they're going in opposite directions, this distance plus that distance is the 225 we're looking for. So just take each of their distances, even though we don't have a specific number from them, take the expression for their distances, and when those two expressions are added together, they should total 225. Now this one, there doesn't have a fraction in it, so we just solve it like we would a standard equation. Get rid of the parentheses, 2.5 times R, 2.5 times 10, combine like terms, 2.5R and another 2.5R. Subtract 25 from both sides. So 5R is 200. So since we're trying to get R, divide by 5. So R is 40, and that's a rate, so that's in 40 miles per hour. So find the speed of each train. So R stands for, or R is 40 miles per hour. So train A is going 40 miles per hour, train B is going 10 more than that. So 40 plus 10, or 50 miles per hour. So it's probably going to ask us for each of those. All right, let's talk about setting this one up, and then I'll leave this one for you as an exercise to solve this one. They want us to find y. And if we look at this picture, we have a couple of triangles. We have this larger triangle that's 5 feet tall, and the bottom side is what we're looking for. And then we have the smaller triangle that's 3 feet tall, and the bottom is 14. So one thing that we know is if we have triangles that are the same shape, and what we mean by the same shape is that they have the same angles in them. Notice the bigger and the smaller triangles, they share this angle. Also, both triangles are right triangles. So by default, this angle and that angle have to be the same as well. So if we have triangles that are similar triangles, then their sides come in a set ratio. What do I mean by that? If we do this vertical side divided by the horizontal side, if we change to a triangle that's that same shape, but is just larger or smaller, the vertical side divided by the horizontal side will be the same ratio. So 5 over that whole bottom side equals 3 over that whole bottom side. And then we just solve that for y.